Good morning, and thank you so much for that amazing kickoff for those of you who are with us. Amazing kickoff to day two with Damon Glover, Steve Bagshaw, and Lord Callanan. I think you have to recognise that's quite a tough act to follow and actually an absolute privilege to have heard. The success of the bioeconomy has been championed by IBioIC, and I'd have to say a huge congratulations to Mark and his team, the full team, for making this 7th conference such a success so far. My name is Jim Laird, and it's an absolute privilege to chair the third theme session on day two, which addresses feeding the world and the role of IB in making protein sustainable. And as CEO of 3F Bio, this is a subject very close to my heart, and I'm very much looking forward to presentations from Deep Branch, Roslin Technologies, and Livalta, which is part of ABIAgri. Next slide, please. This focus on feeding the world and sustainable protein is, as we all know, it's essential. We know the stats on 7.8 billion growing to 10 billion, and approximately 20% of global emissions are linked to the food system. Now, 3F Bio shares a passion for sustainable protein with each of the panelists and their companies shown on the screen. And as a member of IBioIC since 2015, we are absolutely delighted to be part of this discussion today. And again, next slide, please. Anyone who's been at prior conferences knows some of 3F Bio's history, where in 2015, we were one of the early users of the Innovation Centre's scale-up facility in Rapid Bio, and we're wholly committed to making the most sustainable source of protein, and also wholly convinced that the best way to do this is by using biotech and fermentation. Making abundant microprotein with large-scale fermentation is more environmentally sustainable than any source of protein, and it's economically advantaged relative to any of the animal, plant, cell culture, or insect alternatives. In 2016 and 17, with support from IBioIC, Scottish Enterprise, Zero Waste Scotland, we made great progress from 10-litre lab scale, moving on to 1,500 and then 15,000-litre food-grade demonstration. In 2019 and 20, we're delighted to have led and then secured a flagship grant from the EU's BBIJU for 17 million, and this project, Project Plenitude, includes a very strong consortium who cover the full value chain. And it's through this combination of this grant in conjunction with additional equity funding, we're now progressing to an industrial plant that you see on the right-hand side, which will have capacity for 10,000 tonnes per annum. Collectively, we only achieve the targets for net zero by progressing to scale. And for that reason, we have to make food that consumers love, and we have to do it with solutions that do not have negatives in terms of emissions. And then a final slide, please. In that context, we're delighted to have made food from our farm pilot facility based here in Glasgow. That's not what you're seeing on the screen here. And our in-house development kitchen. And we're now very focused on moving towards the large-scale facility shown here, which will be operational in 2022. This will be based in the Netherlands, and we target growing 1 million tonnes of food protein within a decade. If we achieve this, we're one part of the contribution to net zero. This chart shows an image of the plant site where our fermenter scale is 200,000 litres. And if we complete on this, we are one part of the solution to making sustainable protein. This morning, we're going to hear from 3 companies who exemplify how biotech addresses this need. And first up is Polly Douglas, and I'm very pleased to introduce Polly from Deep Branch Biotechnology. Polly was previously with, welcome Polly. Polly was previously with the Scottish Aquaculture Innovation Centre, and with Polly's input and contribution, Deep Branch are making huge strides forward with 2 funded research projects. And Polly, I'm hugely excited to hear your updates and hear the progress since this time last year. And over to you.
Thank you very much. So next slide, thank you. Just my introduction one, thanks. So yeah, just want to say a big thank you to IBioIC and KTN for inviting us to speak. Actually, the conference last year was the only time that I have met my current boss. When I was with SAKE, we ran a side event last year and met him then, and now obviously I work for him, so it's a very nice place to be. So yes, thank you. So as I say, I'm fairly new to this role. I moved from SAKE at the end of last year, September last year, and now work for Deep Branch. I never thought I'd work for a biotech company, but here I am. I have a background in aquaculture though. So Deep Branch is a biotech company, as I've just said. We're based in Nottingham and we're expanding into the Netherlands. Today, what I'm going to talk about is what we do and our plans for moving into commercial scale production. Next slide, please. So just to set the scene, you know, what are the issues that we're trying to deal with here? We know the population is growing. How are we going to produce some sustainably produced food to feed these 10 billion people on the planet? How do we do it in a way that is good for the planet and good for the population? And how do we do it to help reach those net zero targets? Obviously, we know Scotland has a target of being net zero by 2045. 2050 is the global target. How do we do that and still keep people in jobs, people fed, and the planet in a healthy situation? So that is what we are trying to do. Next slide, please. So Deep Branch's solution is to produce protein, but through a gas fermentation system. We create a novel, sustainably produced protein powder that takes carbon dioxide, which can be from industrial emissions, and hydrogen as our feedstock for the bacteria, and create a protein-rich powder at the end of the process. We work with multiple partners, so just to introduce some of them, you know, at one end of the value chain, we have the people that are emitting carbon dioxide and working hard to capture that and, you know, use it, reuse it. So waste to one industry is, you know, a raw material to the next, as we know in all of the circular economy type industries. So yeah, we are working with Drax, who are the UK's biggest producer of renewable electricity in the UK. They burn biomass, and you know, from that burning, carbon dioxide is produced, and they're capturing that, and we can then use that as our raw materials. So we have a small shipping container sized pilot plant at the Drax site in Yorkshire, and we are testing that at the moment. So that's our sort of first scale up from the lab site that we have. We will be moving that shipping container to the port of Rotterdam later in the year, and doing similar sort of testing of emissions there to see if we can run our site in the Netherlands. At the other end of the scale, we work with feed manufacturers, so Biomar, particularly on the aquaculture side, and ABIAgri for chicken feed trials. And then we work with other key partners. So Sainsbury's, really useful to have them on board, helping us with consumer needs and requirements. How do we get our message across, and how does that help to encourage people to eat more sustainably fed fish and chicken down the line? And also SAKE. So obviously I was working with SAKE originally when the big project was being put together. But they help us with that link to the Scottish aquaculture industry particularly. And I apologise, I know I've got the wrong logo. They've rebranded as the Sustainable Aquaculture Innovation Centre, so I apologise for that. Next slide, please. Just to give you a bit of background on Proton, the product, as it were. So it's a very high protein output. It has over 70%. And it has a really good amino acid balance. So the nutritional profile of it is very similar to fish meal, which is, you know, a gold standard within the aquaculture industry, particularly for feed. And it has that optimal kind of amino acid profile. It also contains some vitamins and minerals, which can be helpful to the animals that will feed on it. And as it's produced in a factory as such, it is fully traceable. And, you know, it has a much smaller footprint, physical footprint, than fields of crops or, you know, alternatives. And you know, obviously it's trying to reduce the overfishing and deforestation that is caused by other, like, sort of traditional ingredients that go into these feed crops. We estimate that there's a 75% reduction in the carbon footprint compared to fish meal. Next slide, please. So just to put that into some context, for every 100,000 tonnes of proton that we would produce, which is what we aim to do in our first commercial scale plant. That would be sort of the equivalent of soya growing in an area that is three times the size of Paris, sorry. And so, you know, hopefully we're trying to reduce the amount of deforestation associated with soya production particularly. For every salmon fillet that you would buy in the supermarket, it would have a 27% less carbon dioxide produced around the production of that salmon fillet. So, you know, it would have less of a carbon footprint associated with it. And the traditional ingredients of fish meal and soya come generally from South America. And so obviously we would be able to produce our product more local to the market, as it were, and so we would reduce that amount of shipping needed to bring things from South America, which would be equivalent to 60,000 barrels of oil. So hopefully that would add up, and it would help to reduce greenhouse emissions, reduce the pressure on natural fish populations and the reliance on monoculture and you know, the depleted biodiversity that comes with that. We hope that it will be produced locally to the animals it will feed, and you know, the production will provide a number of highly skilled biotech-based jobs, such as strain development and fermentation scientists, obviously. Next slide, please. Just very briefly talking about the market. So obviously animal feed market is huge. It's 200 billion euros per year, with aquaculture being around about a quarter of that. Deep Branch see that there's a need, you know, that demand's going to grow, and there's going to be a growing gap between supply and demand if we just look at traditional ingredients. So we hope to fill that gap. There are others out there, as we've already heard, sort of plant-based ones, beans, peas, seaweeds, algae, which have other benefits of such as omega-3s as well. Insects, there's lots of species of insects being farmed, and again, good circular economy benefits to those, using up waste feeds, that side of things, and then other single cell proteins. Often they use different feed stuffs to us, so we use carbon dioxide and hydrogen, others use sugars or methane, that kind of thing. But we see that there's a broad, you know, a need for a broad range of different ingredients, and you know, I think the market needs a whole range of things to fill these gaps as they arise. And just to go on to more of like specifically what we're doing, there is, so next slide please, there's a lot of state funding and input and support for these kind of projects at the moment. So just to explain the two big projects that we are running at the moment, and this is where my role in the company comes in. I'm the grant manager, so I am looking after the two big funded projects. So initially we need to produce more proton, so that we can run some trials and things, and we got a Horizon 2020 European Innovation Council Accelerator grant, which started in October last year. This is being built currently in the Brightlands Chemelot campus in the Netherlands, which is down in Limburg in the south of the country. We already have the mobile pilot unit, which we mentioned, which is based at Drax, and that will also be going over to Holland later this year to trial a new site there. So we hope that the Brightlands site will be up and running by mid-March. It's literally currently being built and spec'd out for us, so that's exciting for us. And once it's up and running, we will be producing proton at a level that we can run some feed trials. So our feed trials are being run as part of an Innovate UK ISCF Transforming Food Production grant that we got. This is called React First. And so the chicken trials and work will be run by Nottingham Trent University in collaboration with ABIAgri. And the salmon trials will be run by the University of Stirling, the Institute of Aquaculture, and the feed formulation's been done by Biomar. So again, you can see that we're, you know, the collaboration is there, and we've got multiple partners working together. So the main aim for us this year particularly is to produce enough proton for the trials, get the results, and then do some strain development, process development, and get, you know, everything up to speed and ready for scaling up. Next slide, sorry, last slide. So yeah, our aim is in the next couple of years to build on that production, scale it up, optimize our process, and we are currently looking for a site that we can have a commercial site. So we're looking for a bigger scale production facility. Next slide. Just to say, my contact details are there. If anybody has any questions, I'll answer them later. Thank you very much.
Thanks, Polly. I think that's a phenomenal example of biotech addressing the feed market, clear environmental benefits, and I think it's phenomenal to see the progress and scale up in the last year. So congratulations to all the team.
Thank you very much.
Our next speaker is Professor Jacqui Matthews, who is Chief Technology Officer at Roslin Technologies, and we're moving from feed to the potential of IB in cellular agriculture. Jacqui leads on strategic partnerships and R&D programs at Roslin. She has extensive experience in R&D in funded projects and is very widely published. And in 2017, Jacqui was awarded the RCVS Fellowship. And so we're truly delighted to hear you speak this morning. And Jacqui, if I can, I'll pass directly to you.
Thanks very much, Jim. I'm delighted to be here, and thank you to the IBioIC for the invitation to introduce a little bit of background about Roslin Technologies, and then a bit about what we're doing in the cellular agriculture space. Next slide, please. So Roslin Technologies is a biotech company that is working to transform science innovations to provide solutions to global challenges, particularly in the ag tech area. We're located at the Easterbush site of the University of Edinburgh in the Midlothian Science Zone. And as a company, we are a joint venture between Edinburgh University, who's currently 50% of our shareholders, and two investment partners, Biotrust International via the British Innovation Fund, and JBI Equity. Part of our unique model is that we have a first right of refusal on all unencumbered IP that comes out of the Roslin Institute and the vet school at the University of Edinburgh, which provides us with a platform to many different projects, particularly in the space of ag tech and animal health. Next slide, please. Our main focus is in the area of the protein gap, and with the global human population estimated to expand to over 9 billion in the next 30 years, this will create massive pressure on protein production worldwide. With respect to this, meat output itself needs to double, with dairy and fish production to almost triple in this timescale, which is putting a huge pressure both on the production pipeline as well as the downstream environmental impact and food security concerns. Next slide, please. With this in mind, our focus is to address the protein gap in three main themes. Firstly, to try and increase agricultural efficiency by delivering state-of-the-art breeding programs to evaluate and improve farmed animals. And we already have the revenue-generating projects in pig breeding with respect to this focus. We also aim to support the food chain by tackling infectious diseases in livestock by developing tools to improve animal health and efficiency, biological efficiency, and that includes the development of both vaccines, vaccine delivery systems, and diagnostics for infectious disease. Finally, and the focus of this morning's quick talk is we're developing alternative protein solutions to try and bridge the gap in protein requirements over the next 20 to 30 years. Next slide, please. Our two projects in this area currently are a black soldier fly program, which I'm not going to focus on today, but you can find out more about this project either through directly requesting from me or visiting our website at roslintech.com, and the derivation of animal cell lines and resources to support the cellular agriculture sector. Next slide, please. The cellular agriculture program that we're developing is part of our overall stem cell platform, and we have a unique IP and proposition in the derivation of induced pluripotent stem cells from animals, including so far from canine species and porcine species. The canine species IPS cells we're developing both for therapeutics and drug screening, as well as in the future for gene editing projects. But this morning I'm going to focus on our cellular agriculture portfolio. Next slide, please. Why cellular agriculture? Well, cultured meat is now seen to be part of the solution for future food security. Animal-derived stem cells offer a key opportunity to address the protein gap by providing a nutritive biomass of cultured meat for innovative food projects, addressing in particular issues relating to animal welfare, food safety, and the impact of livestock farming on the environment. Next slide, please. There is a huge increase in the number of companies that are looking at cultured meat, and these are companies' investment and proliferation is based around a number of key advantages of the production of cultured meat over livestock production. Certainly as a sector, it won't replace livestock production, but it'll add as an adjunct to help address the protein gap. And on this slide are just some of the key targets that cellular agriculture addresses in the production of protein from livestock, particularly with respect to this session and conference, the impact of the production of protein from these animals on the environment through greenhouse gas emission, land use and water use. Next slide, please. The market itself is proliferating at a fast rate. And in the last couple of years, there's been I think that's probably over $600 million of investment in cultured meat companies worldwide, such that there's an ever increasing growing number of these companies in this space, totaling at least 40 at the current time. Despite the investment and the derivation of these companies, there are no commercial products currently available for cultured meat, but many products are in development derived from animal stem cells, and the development of these products is expected to grow exponentially over the next 3 to 5 years. As part of that journey, the industry does need fit for purpose tools to develop their cultured meat prototypes, and these include robust immortalized cell lines and media solutions that allow the scale up of cultured meat production cost effectively for the market. Next slide, please. Thus far, most companies are looking at the production of cultured meat from the biopsy of muscle cells from live animals, in particular bovines. These muscle cells are then amplified to produce many cells and are harvested to create a commercial product. A major disadvantage of these cell lines is that they only undergo a limited number of cycles, and so a regular supply is required from the live animals themselves. Furthermore, these cells can't generate cells of other tissue types such as fat, which you would require for the flavour required in the end cultured meat product. New slide, please. Our solutions for the cultured meat sector are based on the production of induced pluripotent stem cells, for which we currently have a patent filed. This removes the requirement for the repeated use of live animals to derive the starter cultures, and that will help to maintain quality of the product through every generation of the media. Furthermore, these cells are reduced to return to a naive state and have the potential to differentiate into any cell type. We have developed iPS cells so far from pigs and have produced a proof of concept to show that they can derive into muscle and fat as well as bone type cells. We are also at the stage in our process of looking at how we can scale up porcine iPS cell production, including in that the production of cost-effective media. Next slide, please. Our cells have been shown to be generally efficient, efficiently sourced, cloned and passaged indefinitely for at least a year over more than 60 cycles. We've shown that subcloning and serial passage it reduces the presence of the vectors that we use to induce the reprogramming, and we have characterized these in detail, including the identification and characterization of the pluripotency and transcription and surface-associated markers. And as I mentioned earlier, I've demonstrated differentiation into the key cell types for cultured meat production. Next slide, please. We're now on our journey with cultured meat, and we've already got commercial customers in this line who are deriving our cells for their own products, and we're currently planning to expand our cultured meat line to different species, including cattle and sheep. We've also done some work with primordial germ cells, and shown here is our prototype chicken nugget that we produced last year, derived from avian PGCs for the production of cultured chicken. Next slide, please. I was quite a cynic, having come from a veterinary and agricultural background as to cultured meat, and I've really been on a very steep and exciting journey with Roslin Technologies in this space. And when you start to look deep, you can see this is a really vibrant space, and the reality of cultured meat is coming soon to us. Most notably, the regulatory approval in Singapore of lab-grown meat for a chicken product in the last month. And the significant amount of funding that's just recently gone in as well to cultured meat from seafood. There's been quite a lot, if you Google, you'll see a lot of studies about how people feel about this and the uptake potentially of cultured meat in the future across different generations. And if we can make it cheap enough, it could even replace some components of pet food. Next slide, please. I'd just like to thank my colleagues Jo and Mel for doing all the fantastic stem cell work that I presented this morning, and that's me finished.
Thanks, Jacqui. I think there's two massive themes you highlighted early on: the protein gap and food security, which clearly are at the heart of this session. And it's really good to hear how Roslin's addressing that. And I hope it's not in the 20 to 30 year horizon, but much earlier. And I applaud Roslin for Roslin Technologies for the role in really accelerating that. So thank you.
Thanks very much.
Our last speaker before we go to panel session, and I encourage everyone to be thinking of Q&A, is Dr. Szopinska. Alex is the Senior Innovation and MPD Manager at Livalta, which is ABIagri's new business for responsible proteins. I like the term responsible. Alex's background is in protein biochemistry, in microbiology, and in food and feed processing technologies, and she's going to discuss new protein sources for the animal feed industry. And I'll pass to you, Alex.
Thank you very much, Jim. Today I would like to tell you a little bit about our journey towards new proteins for animal feed, but also food. Can I have next slide, please? But first, before I start, I would like to introduce ABIagri. ABIagri is a part of bigger and very much diversified group, Associated British Foods, which is active in a number of industrial segments like sugar production, retail, grocery, ingredients, and we are an agricultural division of this business. ABIagri operates in 65 countries, and with its products and services, it's reaching up to 5 million farmers globally. ABIagri has a number of specialized businesses, and I'm a member of a new business called Livalta. Can I have next slide, please? Livalta was formed to develop and commercialize new proteins. We focus very much on the bringing functionality and nutrition in the new products. We aim to contribute to making our food systems more responsible, first by doing more from less. So, for example, adding more value to existing co-products and byproducts. And the second point is focusing on local sourcing of raw materials to reduce this heavy, complicated supply chains. So we build technology and science platforms to keep on innovating our products. And what is important to mention here, we are a startup, even with support from such a big organization. We are a small interdisciplinary group of very motivated people. So I will show you what we are planning to do. Please, next slide. Global requirements for proteins are growing and will be growing. I think Polly already described this topic very well, so I will basically repeat. The global market data shows that the market of protein-rich ingredients will reach 400 million tons by 2020. And as you see on the second graph, we still will be largely dependent on soy supply. So as my colleagues mentioned, on one hand, we will need more proteins, but on the other hand, we need to focus on reduction of land use, reduction of environmental footprint. So we call it protein challenge. And now I would like to show you how we would like to tackle this big challenge. Please, next slide. So as Livalta, we keep exploring number of solutions for new proteins. Among them, developing products from co-product yeast, we call them spent yeast from different industries, but also adding value to plant-based co-products from number of industries. We also work hard on technological improvement of locally grown pulses and legumes. And of course, we look into new, so insects, single cell proteins, algae. This we continue this work with external parties, with the also a large network of research institutions. Can I have next slide, please? I would like to show you a very interesting example of our recent development. It's a new product developed based on spent bioethanol yeast. The product, we called it Livalta Cell. And can I have next slide, please? Overall, the health benefits of yeast and yeast products has been known for ages. And there are also hundreds of publications showing benefits of using yeast products in the animal feed industry. Well-processed yeast products may provide both nutrition and functionality because it's a good protein source, but also yeast cell, for example, yeast cells components may provide functionality, for example, promotion of healthy gut development, immune stimulation, but also it helps in reduction of pathogens pressure. So can I have next slide? Thank you. I would like to show you a small snap from our R&D work. So what were the key steps to develop these products? So first of all, we screened locally available raw materials. We were looking for yeast source, which would be pure yeast, but also yeast strains which are able to synthesize high level of bioactive components. Of course, non-GM, free of antibiotics and heavy metals. So this is all well secured by QC systems in place. The second very important step was process development. For this particular development, we focused on the enzymatic approach. So we did a really big screen of enzymes, which could allow us to first improve the nutritional value of this co-product, but also to enhance functionality. And this work was supported by extensive in vitro and ex vivo testing. And when we get to the right prototypes, then of course, the most important part, we validated product performance in animal in vivo. Can I have next slide, please? This is just to visualize how spent yeast product was modified, was treated with enzymes, and we managed to release all the internal content, so containing proteins, vitamins, minerals. And you can see that this is nicely reflected in the increased digestibility of this product. This is results from in vitro work, pepsin digestibility. Okay, next slide. And the second objective of this processing of spent yeast was enhancing its functional properties. One of the key properties of yeast cell walls, which are important for our industry, is their ability to prevent bacteria from adhesion to the animal gut, pathogenic bacteria, of course. There is a theory based on current model, based on literature, assumes that yeast mannan can competitively bind to the fimbria of bacteria, like, for example, E. coli or pathogenic salmonella, and can block receptors, which then cannot attach to the intestinal receptors. So basically, we can prevent bacteria from invasion. And you can see in this graph, this is ex vivo model of bacteria adhesion, piglet model, how enzymatic treatment of spent yeast could enhance this this property of the product. So you can see that this is actually salmonella binding inhibition. So you can see that there is a massive difference. So you can see that proper processing of the spent materials can improve both nutritional and functional value. Can I have a next slide, please? That was the first example, but of course we don't stop. We keep on innovating, and we would like to really continue work to identify perfect match between raw materials and technologies to develop, we call it future protein, protein to zero. Key requirements for this protein is, of course, local sourcing, sustainability, economics, and consistent supply, quality, and functionality. Can I have just very last slide? So yes, so basically at the last slide there are my contact details. I'm very happy to discuss with members of this great community if you have more questions, and also if you would like to share your results and discuss how we can join our forces to reach these goals, please contact me. Thank you very much.
Thanks, Alex. A really great presentation. And I think, Alex, maybe the last slide comes up, you'll see Alex's contact details. If not, then
okay.
Alex, if you put them into the Q&A. There's some really interesting discussions evolving in that Q&A. And I think it characterizes some of the debate around food versus feed, which is probably a new thing. And if I think back to IBioIC 5 years ago, food and food tech, we felt like the kind of the distant cousin sitting in the corner, and it's interesting to see that this has come full circle. That was our final presentation. If I can ask all speakers to come back on screen, put your cameras back on. We're also going to be joined by Dr. Mike Salter from ABIagri for this final panel session, where you as audience are invited to add any questions in the Q&A, and I see you are already, which is great. Mike is involved in technology scouting for ABIagri for products and service opportunities, and he's got broad expertise in this sector, and we very much welcome you to this panel. And Mike, your camera hasn't yet come back on. So to kick off, we've got about 20 minutes. We'll try and juggle the questions in the Q&A and have some active debate with everybody that's just spoken. And to kick it off, firstly, thank you to all the speakers. Some clear examples of how IB is making an impact in this world of food and drink. And I'm going to continue to welcome you to put Q&As in there. But first of all, I was going to jump in and turn first to Mike, who I can't see, but I'm hoping he can hear me. Mike, ABIagri have been leaders in food. Oh, Mike, let me just check. Mike, are you hearing me okay?
Yeah, I am. It's saying that it won't let me put the camera on.
Well, we've got your voice, which is what counts.
Yeah.
So ABIagri has been leaders in food, feed, and IB for decades. But maybe it seems that sustainable protein is more high profile now than it's ever been. And you've scouted technologies for a long time. Which technologies or approaches, maybe give, as part of your intro, excite you most in this area? And how's ABIagri addressing or viewing this sector currently?
So I think as a start point, my name's Mike Salter. I work for ABIagri. We actually have a central innovation team. So within those businesses that Alex explained, we have researchers within those individual businesses, but then we've recently formed a central innovation team, of which I'm part of. And so I tend to look at broad strategic projects, and the researchers within the individual businesses then look at the more tactical products within those particular areas. As you say, I've been looking at this kind of alternative proteins space for quite some time. I've looked with interest at the single cell proteins, obviously, and the meat replacement technologies, but also for ABIagri, we've been looking for several years now. So we actually had a project on insect protein with Ferra some years ago, 5 or 6 years ago. So it's not brand new to us. But for me, the technologies that are really important are the CO2 consuming technologies. So if you can use CO2 as a carbon source, clearly that's a really good idea. But I think when you look at what Alex was talking about, particularly about the yeast. So you could argue, well, the yeast actually are emitting CO2, but in fact, that's taking those yeasts, as those spent yeasts, as a byproduct, as a secondary, as a co-product, as we would call it. And I think it's really important that within this kind of biotechnology industry, that there's an understanding that there's a possibility, if they have biomass at the end of a process, there's a possibility that it can actually go into livestock feed, and rather than for humans might be extremely remiss to take this kind of feedstock, but of course for the livestock feed industry, it does represent an opportunity. I think some of the issues, the main issues around trying to move into the specifically produced livestock feed protein sources from the kind of biotechnology approach is always going to be cost. It's very difficult to reconcile. If you drive across Middle America, you'll see field after field of soy, and so the cost at which the industry can buy soy is so low, somewhere in the region of kind of $300, $350 a ton, that any competing protein material has to be at a sensible and a competitive price. I think there's, Alex also pointed out the benefits of yeast, and I think particularly as antibiotics are getting taken out of quite rightly, of course, out of the livestock feed industry, it's important that we understand that gut health of livestock is absolutely key. And so these new protein sources, if they can contribute to that livestock gut health and really reducing the need for kind of remedial antibiotics, then they can only be a benefit.
That's great. I think in that last point, Mike, you probably capture some of the questions in the Q&A of this choice between feed and food. And I think in the interest, I think we don't have the time to cover that here. So to some of the questioners, we'll maybe pick that up in the Q&A. But maybe to Jacqui or to Polly, Mike talks about technologies, and you've really pioneered some breakthroughs in technologies which use a more efficient bioreactor than the animal to make something. But can you maybe turn to Jacqui first? Any obstacles you faced in this and anything that's helped you overcome them, and maybe the same question to Polly afterwards.
Yeah, thanks, Jim. So I think probably one of the key obstacles for the cultured meat sector at the moment is cost. And Roslin Technologies is taking the approach that, there's a lot of people working in that space, and we're actually working to try and address some of those gaps. So taking the cost one into consideration is why we've been focused on induced pluripotent stem cells, so that they are generated over time without the requirement to go back to animals. And what we're trying to do with the lines that we've got is to try and make them grow more efficiently and effectively. The other big cost, of course, is the media that goes into that. You don't want to end up spending more on your media to produce a kilogram of muscle cells for meat than actually you can charge. And we're working hard to drive down those costs by scaling up, looking at defining the media, making the media simpler. And in fact, we're working with some people across IBioIC. We put some grants in to look at how we can do a more cost-effective and intelligent scale up, which then we can take to our clients who use our cells as components for their cultured meat products.
Thanks.
Yeah, so things that have been particularly helpful to us, it's that grant funding to help us. The scaling up is always the difficult step, isn't it? We know that it can work in the lab. Getting it up to commercial production it's not just a put more in and hope for the best. It's there's a whole load of technological issues that I can't possibly answer the questions on. But yeah, so the grant funding to do that stepwise kind of development, but also the grants force you and support you to collaborate with partners as well. So it helps to speed up that development because you've got the feedback from the feed companies, for instance, from our partners who are producing the carbon dioxide. So we understand that side of the industry and where the problems are there. And again, that's an emerging technology, an emerging thing that they're trying to scale up as well. So all of that, we're all sort of developing along at the same rate, and the fact that we all understand the issues that go along with that. is really helpful. So being part of a bigger grant project, you know, is really useful, that we can just pick the phone up and go, hang on, what's happening here, or what's the deal with that, you know, and it's actually really helpful. So I have to say that the grant funding and the collaborative working ethic has been really good for moving things forward for us in the last year.
I think it's probably worth a little prompt for IBioIC. Does a great job of putting some grants out there and fostering that collaboration. So I think those in the audience probably know that, but if not, then do reach out. And maybe just on the same question, maybe a question to Alex and or Mike. It picks up on the theme of cost and value, and I see some questions in the Q&A about technology, but saying perhaps ask Mike or Alex how these technologies fit within a food environment that may have a carbon tax. And do you think it's want to proffer any views as to whether you think government intervention and carbon tax is something that's going to play a role in adoption in this industry? Bit of a hospital to pass to one of you.
Yeah, well, yeah, I can have a go if you want, Alex. It's difficult, isn't it? Because if you know, people do not want to pay huge amounts for food. You know, it's a major priority to ensure that food and people see a significant proportion of the population certainly see meat as an important part of their diet and the protein within their diet. And so I think to a kind of a taxation approach would be very, very dangerous for any government. I'm not involved in any way in government, but I think, you know, trying to keep the important thing is to try and get the technologies down to a price where they can compete with the various protein sources that we as an industry have available to us. I think I suspect it would be very dangerous to kind of put a price on the cost of the food that people eat by having a carbon tax on it. And don't get me wrong, I'm not trying to escape this, because as has been explained by Alex, and hopefully I've explained briefly at the start, we as an industry understand this, and ABIAgri and I know other industry members understand that we need to try and work towards this, and it's obvious from the work that Livalta's doing, we are trying to do this. So we're, you know, I think anything that increases the price of food, though, is very difficult to justify.
So let me maybe be more provocative then. The theme of the conference is net zero and impact. So we move on to that net zero. I think we all echo the desire that technology gets there itself and gets to efficient and competes in its own rights. But how fast do you think we can get to net zero? And within the food system, what change or help would you want? And if we're dispelling the government intervention with carbon tax, what would you hope for to make this happen faster or fast enough? And I think Steve Bagshaw and Lord Callanan did a great job of characterizing we need to do it fast enough. So Alex, maybe if you want to go first on that one, any desires in that sense?
So I think there are many ways we can as industry do our best to accelerate this process. First of all, I believe the collaboration between different branches of industry is key here. More strategic thinking, but together. For example, if there is a plan for a new plant, let's already plan that CO2 emissions will be used for algae production. So really strategic thinking. Also, what is our philosophy as ABIAgri, using all these co-products, all that is typically regarded as low value or waste, we can still put it back to the circle, to the cycle, and we can still make a lot out of it instead of building completely new processes. So I think there are many things, and of course the communities like this one, innovation people, I think they will play a huge role in really accelerating this process towards net zero.
Thanks. Jacqui, do you have a view on the same subject?
Yeah, no, I think, you know, I think it's going to have to be working together. I think it's really hard to put a date in it. ASAP would be the thing, but I think, you know, there's so many branches to how we can achieve net zero. And I think conferences such as this and regulatory mechanisms push through the system will someone's mentioned the carbon tax already, but, you know, initiatives like that will push us. But, you know, I don't think it's not going to happen overnight, but it's going to require, you know, cross-industry, cross-legislation promotion to get us there. You know, and I get, dare I say, you know, with that legislation comes a negative impact on those that aren't addressing the net zero issues within their organisations.
And Polly?
Yeah, I mean, I think I've not got much to add, but that regulatory, the policymakers need to be in line with, you know, the industries, those wanting to make the changes. Like, are we allowed to make the changes, and can you please allow that to happen as quickly as we need it to? And then also the sort of investment, the big capex, you know, like, we can't do this with the infrastructure that exists already. We need new buildings, we need new infrastructure, and for that we need investment. So, you know, IBioIC sake, you know, other innovation centres are great on the sort of ideas generation side, but we need that sort of bigger level, down the line, continued investment into these enterprises, so that those ideas can grow and can get to commercial scale. So I think that those are the main things.
There's an interesting question in the Q&A there about once industry scales up, and it probably picks on your point, Polly, there seems to be little space, and it's from George Allison, little space for smaller operators, barriers to entry become massive. Is that, would you go with that? And I think from your own company's position in this, you're transitioning from the small company to the big company. So would you agree with George's challenge?
It is, you know, it is difficult to go. Lots and lots of people are having ideas in the labs, and, you know, we see this all the time, and there's encouragement to spin out from universities and that side of things. But you know, Jacqui said earlier, it's really expensive doing it on that small scale, and to make it worthwhile and to make it commercial, you need to scale up, and that's when the prices come down and it becomes an actual commodity in the market, as it were. And there seems to be that mismatch of getting it from the lab right up to commercial scale, and there is support there, but it's, you know, it's hard fought for, it's difficult to access. You need to know exactly who to speak to, and you need a lot of luck, I think, you know, a lot along the way. So yes, there are great ideas out there. It would be nice to see more of them, you know, forging ahead and being able to grow.
It up as a sales promotion for IBioIC, but again, the innovation centres, the scale-up facilities help on that journey. We are going to run out of time, so I've got one last question, and we'll try and go around each of you. So I'm going to offer you 2 wishes. So if you had one wish or ask for the whole industry, what would it be? And maybe you've already covered it. And therefore, if there's one thing you wish for your company in the next year, what are you asking for? And you've got a minute each. So Mike, why don't you go first?
Yeah, my camera's suddenly been turned on, which was very good. Yeah, I think I'd wish that, I think as Alex said, that we can work together, because basically, you know, it's about providing channels to market. So you have to go right the way through to get these kinds of products. And I think it's why I'm really pleased that as a business we created Livalta, because we were creating a channel to market, so that when these new products and these much more sustainable products became available, they've got to get to the market somehow. And, you know, with the best will in the world, a company that's kind of designed and come up with a really new concept for a biofermentation system that produces a CO2 consuming protein, at the end of the day, they're not walking down farm tracks. We are. And so it's really important that we all can work together, you know, and that people who businesses that think they have sources of protein, you know, and think, actually, could we use our byproduct, our co-product as an animal feedstock, both for an increased an improved return for them on their process, and in which case then they can contact people such as Alex, myself, and other businesses within the industry. You know, it's not only ABIAgri that's doing this. The industry as a whole, the livestock industry, is trying to do this. So I think it's really that we can just, as a whole space, maximize the potential for these new protein sources and these much more sustainable protein sources.
Thanks, Mike. As we're doing it, and I'm going to Alex next, but as we're doing it, I think maybe all panelists, Mike's message is collaboration. So all panelists, if we can make sure contact details are in the chat, then people can follow up and do this collaboration. But Alex, same question to you. You've got a couple of wishes in a minute.
Yes, I would confirm what Mike said. So basically more and closer collaboration between different branches of industries to understand this common objective and to really work together to get there. So that's my wish.
And Polly?
Yeah, I mean, I think collaboration is a big one. And as I've already sort of said, that all working together, the investment, the backing, the government support, let's push things forward and get things out there. And then my second wish for my company is a very selfish one. I started my job in September and I've still not met any of my colleagues. So I would like to be able to travel and move around the countryside a bit more. Not really specific to this topic, I know, but I think, again, that it adds to the collaboration conversation, like being able to meet people, see people, I think it helps. And that would be nice.
Jacqui, why don't you round us off?
Yeah, so finally, I mean, for me, especially with the animal cells work that we're doing and the insect protein, I think meeting more people in the value chain, as Mike said, can we help people with their waste and how can we put that into better black soldier fly lines and make the connections across industries with the animal cell lines? Can we work with more people with scale up and nutrition regarding the potential of our cell lines? And I think for our company is the growth. We put a lot of effort in the last 2 to 3 years into developing these innovations, many of them from scratch, and just to see uptake further down the value chain with those, it would be great. So a kind of upscale for our experiments and growth for our company.
I thank you all. Thanks to all the panelists. I think there's a number of debates which are there for another day in terms of the feed versus food debate. And for all the questions that haven't been answered, we'll try and cover them off in a moment. I think the trends there are collaboration, value chains, and travel. So maybe some closing remarks. My wish in this area is that we capture this moment and capture the energy for non-animal protein sources, because we have to. And we'll only create, I think everybody's echoed it, we only create impact by having the right resources and that abide collaboration. And we need to encourage all the talent that is needed to succeed. So I think some great comments in the earlier session and some great energy from people here. I echo, Polly, your message that I fervently hope we can see the success of IB and celebrate the success of IB in supporting the vaccine rollout, such that we can all return to freely travel. I think this conference is a great example of doing it virtually, but there's also some benefits of face-to-face. So thanks to all the panelists. That's going to conclude our session. For those of you who get a comfort break, the next session is going to be on growing the economy, the bioeconomy in Scotland, and it will be chaired by Liz Fletcher, the manager from the UK Centre for Mammalian Synthetic Biology in the University of Edinburgh, and that will be back online at 11:40. Before that, we will see the final presentations from the IBioIC's PhD students. I hope that you've already seen some of them, and we will have a short comfort break for 15 minutes. But again, thanks very much to the panelists, thanks very much to the presenters, and let's keep on fighting with those impact and making that impact. Thanks to all.
Thanks, Jim.
Biofuels are alternative fuels made from renewable sources such as wheat, corn, or waste cooking oil. They can be categorized into different generations, with the first being fuels derived from crop plants and animal fats, the second from non-edible plant matter, and later generations from algae and microbes which grow in carbon dioxide. Biofuels are a sustainable alternative to traditional fuel production from petrochemicals and consist of bioethanol and biodiesel. In the current ecological climate, it is expected that the value of the sector will rise due to governments tackling current carbon dioxide emissions, as well as society becoming more conscious of their carbon footprint. In the UK, the majority of biofuels are produced from used cooking oils and corn. Scotland has the potential to produce 170 million litres of bioethanol annually from sugar beet. However, several factors need to be considered before this can be deemed feasible. For example, the location and size of arable land, where processing factories are located, and what the transport infrastructure is like in the proposed areas. A no-waste approach is the most desired process, utilising every part of the sugar beet, for not only bioethanol production, but for high-value chemical production, and the byproducts produced can be used for animal feed. There are many different methods of producing biofuels which are still in development, with particular interest surrounding microbes that can live off flue gas for bioethanol production, and microalgae which can use sunlight and carbon dioxide for biodiesel production. A combination of the approaches may also need to be considered in the future, as to not rely on only plant crops or microbes solely.